Well, it's exciting to see all the talent we have here in this room today. Startups, large companies, investors, all gathering around the same topic that we want to talk about, the new wave of robotics, an event that is co-hosted by Synapse and Silicon Valley Robotics. My name is John Robbins. I'm a director with Synapse focused on our robotics and industrial business. Just want to take a minute to talk about Synapse and introduce Synapse. Synapse is a product development and engineering consulting company, and we help ambitious companies to bring their ideas to life, all the way from concept to prototyping to production in many different fields, consumer, medical, industrial. And it's our mission really to build products that make a positive impact for people and the planet. And today, as you can see, we are focusing on the planet side about how technology can make a positive impact on our planet. We have built so many different products. Just to give a quick example of some of the products that we have built. We have built a robotic companion animal for dementia patients, a vertical farming robot to reduce land use, a direct air capture system that can pull 100 metric tons of CO2 out of atmosphere every year. So while we are engineers, we also have this passion to make an impact in our world. And we believe that climate change is one of the biggest challenges of our times. And at the same time, we also believe that advances in technology, specifically in robotics, can help fight that challenge that we have. So we have lined up an amazing team of speakers today, starting off with a keynote with Keegan Kirkpatrick, whom I will introduce in a bit. Following that, we will have a panel discussion led by Andra Keay from Silicon Valley Robotics. And then we will have a breakout session where we will have 5 different discussion groups around this space, ending with some cocktails and networking. And so thank you for coming, and I hope you have a fun day today. The day is packed with a lot of information and insights, and so I hope that we will give our full attention to our presenters. And I would request you to take any side conversations. Oftentimes when there's a conversation here happening, it might stir some conversations. I would request you to take some your side conversations, maybe to the lobby area in a closed off room. And likewise, I'm also going to request you to please silence your phones, and I have to remember to do that myself. And if you need to use the bathroom, please sneak out through the lobby. The bathrooms are behind me on this side. With that, I want to introduce Keegan to you. Keegan Kirkpatrick is an aerospace engineer turned entrepreneur. I looked up your LinkedIn profile, and I want to read the words that you have on your LinkedIn profile. He says, "I'm the guy that never stopped wanting to be an astronaut when I grew up. I started my career working on rockets and satellites, and now I'm working to bring technology made for Mars back to Earth." Founder and CEO of RedWorks Construction Technologies and a founding partner at Space Advisors, Keegan has spent his career building companies that marshal new technologies in robotics, biotech, and spaceflight to shape the future. Today he'll be talking about the world after the supply chain crisis, focusing on sustainability and supply chain. Welcome, Keegan.
All right, thank you. Let's see if we can get this thing to cooperate with us today. Okay, so as John said, I'm Keegan Kirkpatrick, CEO of RedWorks Construction Technologies, consultant at Space Advisors, and I'm here today to talk to you about the great crisis of our time. Today, the price of everything is going up. Our dollars aren't going as far as they used to. The basic things we need for industry or just daily life aren't getting from A to B at the pace that we expect and demand of them. This is the face of the global supply chain crisis. This in particular is what most of us think of when we think of global supply chains. Standard shipping containers, shipped across the world by train, boat, diesel burning truck. 226 million of them a year go from port to port, town to town, factory to factory. All told, accounting for around 1/5 of global CO2 emissions just in their transport. And of those 226 million units, they make a massive impact on the day-to-day lives that we all have to live. In the United States alone, the world's largest consumption economy, they account for around 40% of all of our entire GDP. Another 4% or so going primarily to import services. An important sector, but I'm not going to spend too much time on that for convenience sake. That's a lot of different spots in which even if a tiny percentage of those containers don't get to where they need to go, life gets interrupted in a bad way. Unfortunately, there's some pretty significant trends in the world right now that are making a lot of interruptions in those supply chains. Now, before I go any further, I want to stress one thing above all else. This is not just about COVID. COVID is important. COVID did a lot of damage, but COVID really moved the needle on trends that were already going on. Whenever we talk about the global supply chain crisis, we tend to get a little tunnel vision on it, and people tend to talk primarily about COVID, instead of a lot of factors that, frankly, we were warned about for decades. The big four that we'll be spending our time on today has been the mass retirement of the baby boomers, a global slump in immigration, a tech sector stagnation, if you will, and climate change above all else. All four of these combined have caused interruptions across the supply chain. The tech sector stagnation is arguably the least important for the purposes of our conversation, but it is important to know that the contributing factors to it are actually coming from these first two factors. So, the baby boomer retirement. This should not be a surprise to anybody. It was written about for decades. It is just basic math. The problem has less to do with the fact that the baby boomers are leaving the economy and more to do that there aren't enough people coming up behind them to replace them. Not just replace them, but cater to their needs as they become retirees. Now, a lot of people, particularly in the US, have a idea that this will probably just be made up for with an free influx of immigration coming over the US-Mexican border, but that idea stopped being a reality around 10 years ago. Immigration absolutely cratered between 2012 and 2017, and we're now looking at 2 million fewer immigrants just to the US as of 2020. And the United States is actually lucky among advanced industrialized countries in that while we do not have the desired pyramid demography, where you have a lot of young people coming up behind you who can be in the workforce and a relatively small amount of retirees, you'll notice that there is a major tapering coming out at the bottom there, but otherwise it's just this solid log of generations that are roughly the same size of one another. The 2.3 kids come home. The US, I say, is lucky because countries like South Korea are facing absolute demographic collapse right now. And if we were having a surge of immigrants that could fill this hole, we wouldn't be seeing demography like this at all. Now, what that means is that we simply do not have enough working age people to be able to fill the gap in the supply chain. And this is hitting different industries harder than most, but it is going to hit all of them eventually. The reality of the situation is that when you take a large demography like the baby boomers out of the economy, they not only take their investor capital away with them, hence the global capital crunch that a lot of us are feeling right now. Some of us in this room who are entrepreneurs have probably noticed that very firsthand. We are also seeing that the applied knowledge that they brought with them, the contacts and experiences, and just the general day-to-day understanding of how to do business leaves with them as well. So even if millennials and Zoomers and eventually Gen Alpha were the most efficient generation on the planet, they cannot reasonably be expected to make up for this shortfall in productivity. Now, the final contributing factor to the global supply chain crisis we normally don't think of in that regard, and that's climate change. Extreme weather events are becoming a more common sight all around the world. Just in the last month, we've had over 200 container ships that were blocked at the Panama Canal because there was a significant drought in Panama that prevented the locks from filling up high enough for ships to be able to go through them. From the impact that hurricanes have on major energy supply chains like oil industries, particularly refineries in the Gulf Coast of Mexico, to things as simple as whole port towns being knocked out from major flooding and hurricanes, climate change is causing massive interruptions in the basic logistics that we all depend on to live. So what is the solution to this? Shrink the supply chain at every step that we possibly can, reduce the vulnerabilities. And another way to put that is automation. Automation and shrinking supply chain is not just about displacing labor. It is about reducing the number of trucks, trains, and ships required to get materials from A to B. The amount of diesel that we have to burn, and coal in some cases, to actually operate the economy at large. Fewer steps means fewer transportation, means fewer people to operate them, means an overall efficient and more sustainable supply chain. Now, we know this works. We've seen it work already in large-scale industrial manufacturing in the auto industry going back 50 years now, to more precision manufacturing that is brought on by the 3D printing revolution. The aerospace industry in particular has grabbed hold of this with both hands, to supply chain logistics in warehouse logistics. And to a significant extent, I'll just make mention of it really quickly, in the project management software that is designed to really get the most use out of this diminished labor force we now have. But that itself is being somewhat constrained by this stagflation that we're having in the tech sector. And this is why robotics is so important, to offset that wherever possible. Oh, hang on. Uh-oh. Oh, doesn't that just figure? Okay, here we go. So for my money, there are three main industries we're going to cover that can have the largest impact on both climate change and disrupting the labor pool as much as possible. Number one is the one that I operate in, construction. This is an incredibly conservative industry that has that is undergoing a massive wave of new demand for construction, but is so decentralized that there are just a ton of different middlemen that the industry absolutely depends on to survive, and a lot of people who are looking for the door in terms of retirement. All that told is leading to a rising budget, rising costs across the industry of around 14.1%. I am apparently have angered the clicker in some way. This is particularly damaging from a social standpoint because we are facing a 300 million unit global shortage of available housing. And those numbers are probably padded a little bit depending on what government sources you're willing to believe in. Okay. This is a $14.4 trillion industry as of right now, accounting for, just in the production of basic masonry, concrete, 7% of all global CO2 emissions. I recommend you all start taking notes. I'm going to be mentioning these CO2 emissions. The bottom tally is going to be staggering at the end of this. This is also an industry, by its very nature, that often has to build its own supply chain, so it's even more vulnerable. If you're building a new construction site, it tends to be on bare ground. You have to often build your own roads, power supplies, everything to get there. So the more we can disrupt that, the better. Fortunately, this is an industry that is finally starting to take the right direction in this. Partly because of the amount of capital that is now going towards trying to take advantage of new home construction, there is a bigger push in the business community to try to take advantage of construction as a new avenue. Why is this being such a... There we go. Nope, we went too far. Or did we? Hang on. There we go. Probably the most visible example of this has been in concrete 3D printing. Now, concrete has a few drawbacks here and there, but if you can at least disrupt the supply chain of labor at the build site itself, you're going to make a pretty substantial impact just in supply chain logistics to get material there in the first place. Construction tends to be very wasteful. If a brick is not fitted right, if a mold is not made right, you end up having to throw the whole thing out and start over. So 3D printing for concrete ends up being a big waste saver. But beyond that, we can get into, okay, this is just, there we go. We can get into more advanced systems that take advantage of existing feedstocks in the supply chain, like bricks, cinder blocks, etc., and further automate construction and make it a more mobile process. This is done with folks like Robotics, who have developed new advanced bricklaying machines. Really not all that different from a cherry picker, really, in terms of how they're built out. They're a truck that can just get to the build site. But to really make construction truly sustainable, to take it one step beyond just making iterative improvements into how it impacts the supply chain, we need to get to the heart of the problem, which is the supply of materials itself. And this is something that is going to be important for all these industries. And that is what RedWorks and a number of different companies that we've dealt with in the past are all trying to do right now. From trying to directly sequester carbon dioxide as a binding agent for concrete, to the use of advanced biomaterials like mushrooms, to what RedWorks is doing, which is an advanced sintering process, literally fusing your excavated dirt you dig a foundation with to make brick and material right there in the build site. This allows us to offset the need to bring material there in the first place, completely disrupting that entire supply chain. Now, this is very much a work in progress, but if we can get to a point to where we're not reliable on nearly as much labor at the site itself, or these various various phases of labor up the market, that is able to have a major impact on this industry. Next, and speaking of direct sourcing materials, there's then mining. Now, mining is a fairly dirty industry. That shouldn't be a surprise to anyone. It contributes between around 5 and 13% of global CO2 emissions per year, depending on what sources you cull from. But it is an industry that is arguably in labor pool collapse right now. It would be easy to blame certain not particularly flattering instances of cave-in, of collapses of mine shafts and things of that nature, but it really boils down to that a lot of the demographics that are pulled from to hire new miners have newer and better opportunities available than they used to, and they're just not willing to take on the risk like they did anymore. Now, that is overall a good thing, but this is an industry where we get all of our stuff from at the very basic level of the supply chain itself, and we are in dire need of new labor to be able to fill that gap. But the good news is this is an industry that has arguably been more accepting of automation and robotics than anybody else since at least the auto industry made the transition. From the private sector to university projects that are building small-scale mining robots, we're seeing a lot of work being done to be able to make it possible to be able to extract raw ore without having to put a lot of human lives in danger. Now, one source of this innovation that often goes ignored, and the robotics community is arguably more instrumental to the aerospace business as a whole, so I don't know how much of this I'm probably repeating for the people in this room. NASA has been a massive source of innovation in robotics, particularly for the sourcing of raw materials for the Artemis program. NASA figured out a long time ago that if they intend to do anything long-term in space, be it on the moon or Mars, they need to be able to disrupt the labor pool as much as possible, because I don't know if you've looked at the cost estimates recently for the Artemis program, but it costs around $1.5 billion per flight to conduct one of the SLS launches, and that's around 7 people that it would be able to put on the moon. It's not exactly what we would call a scalable supply chain for sourcing materials. So NASA has been outsourcing the development through the SBIR process, the STTR process, to be able to bring on and drive innovation for the sourcing of ice and raw materials, and I highly encourage anyone who isn't already looking at this to examine NASA as a potential source of revenue to be able to foster the development of new technologies. Other companies have actually gone the other way. Offworld, a startup that actually began examining the development of robots for lunar mining, has since redoubled those efforts to take the same technology to be able to put those robots to work in mines on Earth. So this is something that can have a very positive development feedback loop for the development of new technology. The third and final sector that can be disrupted by all this is agriculture. Now, I spoke to a few of you before I got on here, and I'm glad to see that the agriculture robotics community is being very well represented at this event. This is an industry that is, without a doubt, the largest source of CO2 emission, period. We're talking 35% of global carbon dioxide, greenhouse gas emissions just from ag. It is an industry that is facing rising land prices from the same problems that we talked about earlier in the construction industry. As it gets harder to build new homes, prices go up, and the ag industry, unfortunately, has been hit by that as well. It's an industry that is under extreme stress from extreme weather events, and it is arguably the most geopolitically risky industry on the planet. Anyone who knows their history in this room well at all will know that nothing changes governments faster than the price of bread going up. And unfortunately, that's what we've been in for the last year or two. The Ukraine war can best be summarized as the world's largest wheat exporter going to war against the world's 5th largest wheat exporter. And particularly in the developing world, this has seen massive reductions to the availability of their most basic staple calories. More than that, the ag industry is also now facing a global shortage of nitrogen, potassium, and phosphorus fertilizers. This has hit, other countries have been doing their own exporting here and there, so this data is probably not 100% up to date. They've been able to reduce their own export and try to offset, we'll pull in fewer nitrogen this year and use more of our own phosphorus. But we are looking at a significant reduction in the availability of the essential inputs needed to be able to conduct global agriculture. This is where automation has been doing work in a way that we don't normally think of when we talk about automation, and that's passive automation. Greenhouses are an immediate and easy way to be able to control the flow of these base inputs, and particularly to make your agriculture products a little bit more resistant against extreme weather events. Almeria, Spain is probably the most extreme example of this, where they've actually, and in a roundabout way, are doing more to combat climate change on 2 fronts. Not only are they reducing the input of nitrogen fertilizers and all the things they need to be able to operate that, and all the different change in the supply chain, Almeria is coated itself so much in new greenhouses that it has actually increased the Earth's albedo of this little peninsula in southern Spain to reflect more sunlight back into space and reduce the impact of global warming for that one specific region. We'd have to do this on a much larger scale. Nevada would have to be like white from orbit for that to have a major effect. But still, the next step on this is, of course, robotics itself. From optimizing systems that tend to depend on people on an individual level, like being able to do pesticide flyovers and watering of whole fields, to being able to improve the efficiency at the actual farm site itself. The less we can rely on humans to weed a field, that's less farm labor required just during the growing season itself. And companies like Carbon Robotics here have taken that by using industrial lasers to go through a field and plant by plant identify and zap any weeds they see. If the ag industry can get through the capital problems that this solution, I admit, demands, and the adoption of robotics at large, it could make a serious impact on the amount of labor required, the amount of people required just to get them to the site in the first place. More efficiency means less of an impact on climate change as a whole. But there is a whole host of new technologies that I'm not able even to cover here right now. From advances in the biotech space for engineered proteins to 3D printed meats that are able to offset the use of cattle, which are a major source of CO2 emissions, to being able to just improve the overall direction of food to, literally farm to table by being able to reduce the area required to farm. All of this has a massive impact on global food security and can make the supply chain that much more efficient and more sustainable. Now, for those of you who are doing your math during this conversation, you should know that the three industries and the supply chain itself, all combined, would account for a reduction in CO2 emissions of around 75%. This is a massive potential impact just from three industries. And for those of you who aren't working inside this directly, that's a whole 25% extra that I didn't get a chance to mention that you guys can take a bite out of. So with the threat that we are facing from a global shortfall of labor, with the threat that climate change is facing, the new technologies being developed in this room today have a massive impact they can make on making not just our economy more sustainable in a green sense, but more sustainable in how they can stand up to interruptions and keep our lives moving without any massive price spikes or any of the unpleasantness that we've come to know in the last few years. Thank you all very much.
So thanks, Keegan, for that presentation about minimizing dependence on supply chains and bringing the production closer to the customers. We have a few minutes to engage with Keegan. If you have any questions, feel free to ask.
Check, check. Does this one work? Okay.
Okay. Hi, Keegan. I think you mentioned at the beginning that if you add up all the emission numbers, the greenhouse gas emission number, it will be a staggering number, right? So I think if I followed what you were saying, I think the first one was like what, 7%, and what's it?
It was 7% for construction, 5 to 13 for mining, 35 for agriculture, and then 20% for the actual delivery of all goods in the supply chain itself.
So in the end, it was what, 75?
75, knock that down by 8 to a little, depending on if you're having a good year for the mining industry, yeah.
So basically you're saying that like transportation, like personal transportation, like driving cars or something, it doesn't account for that much or something?
Well, that's considered in the overall transportation figures because if we're not just talking about diesel burning big rigs, we're also talking about little hatch vans, delivery of small goods to the site itself. Okay. I didn't mean to minimize that, okay, but it was a broad number.
Okay, good. Yep. Yeah, that's pretty large, 75.
Yep.
Thank you.
Okay. Thank you very much, first of all, for a wonderful presentation. I think you summarized many themes so concisely, so well, very well delivered. So I just want to give you another round of applause for that. That was fantastic.
Well, thank you.
So, Johan Hugo Gutierrez, one thing I look at is always, I love efficiency. I think we have a lot of parallels and things we were passionate about since we were young. one of the challenges as we look towards some of these solutions is how do we power all of this, right? And when we look at power source, power store, it's not that we don't have enough power, but of course, power capture, power storage. So we look at a lot of work being done around battery technologies, but also alternative fuels as well. And I'm not just talking about, biofuels, as you know, there's a number of different options out there. And I'm curious from your perspective and what you're seeing out there. It sounds like you're obviously paying attention to a lot of the things on the cutting edge. What are the solutions you're seeing that are holding promise? Because as we look at everyone rushing to electrification, for example, well, nobody was pragmatic or thought about what that actually means and what it costs, what are the mining implications, all this. But there are a lot of technologies out there that are alternatives. And I'd love to hear your perspectives, thoughts, and how you think we're going to address some of these.
This could be an entire talk without breaking a sweat, so I will try to keep this short, and we can talk a little bit more afterwards if you like. Short version is that the problem we're facing with the electrification of the power grid and the adoption of new renewable technologies is really that federal and state governments have done what they love doing best, which is abrogating responsibility to the private sector as much as possible. There's been a big push to build electric vehicles, new incentives for being able to build renewable power systems, but there hasn't been a big push yet, at least in the US, to build better battery storage systems, to modernize power grid systems. I don't think that's going to be long term. We've already seen in Australia and Southeast Asia at large an effort to try to improve the availability of large battery plants as an element of a public utility. Right now, probably the biggest thing holding it back is really real estate prices and governments not really wanting to be known as the bad guys who had to tear down a whole neighborhood to build a massive warehouse to hold batteries. I think as the problem gets more severe, that risk reward from a political perspective will shift a little bit. Now, I am willing to bet that you, like a lot of people, were holding their breath, hoping that LK-99, the purported superconductor out of South Korea, was going to actually be a superconductor, and like me, very, very disappointed when it turned out that it wasn't. That does not mean that new technology development for better battery storage, for better transition technologies is either not happening or should not be given more research. And I would argue that that's probably where the government needs to put most of its energies into. I would love to throw DARPA at this problem.
All right, so going back to sort of the construction specifically, construction industry, looks like you're working on something that turns basically dirt to brick, which sounds great. So question on that is, A, where is that applicable and where is that not applicable, certain environments? And then also, where do you sort of see low carbon concrete, that development there? Where is that coming in? How's that ramping up? And sorry, how do you see these two working with or against each other?
All right, without turning this into a whole pitch for my own company, the short version is that what RedWorks is doing is developed we have a patented process for induction printing of dirt and sand into usable stone materials. It's a material that's actually called welded tuft. It's really common around the Mediterranean basin. The Romans essentially mined it to extinction around kind of the there's a volcano in what is now Santorini, Greece, that was the main source of it all. It blew up, I think, like 35,000 years ago and ended up being a source there. Our process is a lot faster and a lot less destructive, but because it's not relying on a lot of the same processes that go into the production of concrete, it's a significant reduction in CO2 emissions on its own. We've tested materials from all over the world. One very weird part of my job for a stretch there was calling up people and telling me, "Can you send me a bag of dirt? I need a bag of dirt from your backyard." And I've got samples from Dubai, from my own backyard, decomposed granite growing outside the San Diablo Mountains. The only things we've found that are a hard no are topsoil, which you go about 3 to 6 feet down anywhere in the world, and that's generous in most places. You'll hit the feldspar-rich soils that most of the planet is actually made out of. Diatomaceous earth, hardly anywhere to use that unless we're trying to build with the top slough of material from seawater. And calcium carbonate sands, which are only really found right around coral reefs. If we don't use any of those, it works a trick. And that's assuming we don't add any more traditional dirt or even metal as a potential binding agent to get around that. As for low carbon concretes, this has been a struggle in the materials industry for a long time. I'm not saying that it's not worth the struggle at this point. but as I have a vested interest in saying so, I'll say it's not worth the struggle at this point, and everyone should use my stuff instead. But I think there is not a single solution for this. Low carbon concretes are something that can be done. There's just really a problem that the construction industry is extremely conservative, and a lot of the ways to achieve low carbon concrete, you essentially have to export a chemistry lab out to the build site itself. And the second you have to sell that to anyone who works in construction, an actual contractor, they are going to want nothing to do with that. So if that process can be refined to something to where the builder doesn't have to really think about it too much, just plug and play, it'll go off without a hitch. But that's the big hurdle for low carbon concrete.
Hi, great presentation. What does it mean for the construction industry to be conservative, and what challenge does that pose in communicating the value of your product having a firmer supply chain?
Okay, I'm guessing most people in this room have never worked construction, never gone to a job site or anything like that. Few folks. I see a few folks who had an honest job before getting into this line of work. I was bottle fed on this industry. My dad is a finished carpenter. He builds staircases for a living. I helped pay for college, well, tried to anyway, doing remodel work and journeyman work on houses. This is a business that is very, very much done on a handshake basis. It's done with a lot of old friends, and it's done with guys who are very, very risk adverse. Construction workers are very much the canaries in the coal mine. If you ever want to know if we are in for a massive housing shortage, just talk to your average, leatherneck construction worker, and he'll tell you if we're in a bubble or not. These guys are used to having their whole lives wiped out every decade or so when another bad housing shortage comes in. And if they have to deal with anything like that, it tends to make them very, very suspicious of new technologies, which to them means more money I now have to spend to bring on new hardware. So what has been shifting in the construction industry is that as a lot of those old guys are retiring, a lot of that kind of interpersonal business culture that they had is leaving with them. And actual startups are moving in to kind of fill that gap. That means that we have a degree of centralization and the capital base required for folks to take on risks that they wouldn't normally take. I hope that was succinct enough. Anything more than that, I'd have to start naming names, and I would like to go home for Christmas at some point in the future. So, yeah.
Let's see if this works. So you mentioned that the construction industry is conservative, but are the insurance companies conservative as well when it comes to using new materials or new techniques?
Less so than you'd think. It really depends on the region. We really built our company on the logic that, this would be something we'd have to use on like facing stones, non-load bearing structures for a few years, landscape architecture. That has shifted in a massive way just in the last 2 years. I've had a couple of would-be clients who, now they often choose counties where I get the suspicion that they only have like 3 laws and that there's probably not a lot of pushback there. But there is a greater and growing desire to just onboard the risk that comes with operating new technologies, simply because if they don't, they're not going to have the labor pool available in the first place to even make their money. So really, they're trying to avoid the whole industry seizing up at this point. I'm sorry.
So aging population really hit a lot of the trades, especially plumbing and electrical. In electrical, we're starting to see increased demand, and there's worry that as laws change, you're going to have to electrify things. You won't be able to buy gas in California. There are no electricians who are coming on the market to provide that service. And I've seen plumbing startups, I've seen drywall startups. I haven't seen anything in the electrical space to help with this, and I'm curious if you've seen something.
Unfortunately, no. And California is not unique in this at all. I have a few friends of mine back up in Washington who were gainfully employed longer than I was out of college because they went into the trades instead of STEM. One of my buddies was an electrician for, I believe, a BMW dealership or something like that. Never actually apprenticed under anybody. He got hired and put onto full-time labor immediately the second he switched to going to actually be a union electrician for, I think, Seattle City Light now, just because they were that desperate for the labor. They said, you're going to be an apprentice on paper, but we're giving you the full responsibility and full-time job. Now, he's very good at what he does, so I sleep at night okay there, but I know a lot of his friends all too well, and I sleep a little less knowing that they're the ones keeping my power running on a daily basis. But then again, you should meet some of the people I know in the aerospace business as well if you ever want to lose sleep. Yeah, unfortunately, I have not seen a lot in electrical startups. It is something we desperately need. The fact that we have drywall hanging startups is really encouraging, but we are very much at the beginning of all this. RedWorks is the fact that we're just solving the material side of things is really one important, but still very small part of the construction industry at large.
So just really quick follow-up on the tying Nevada and the comment on some of the electrification pieces. So I'm not sure if you followed, for example, Nevada, we had tons of our friends went in there, invested in all kinds of everything, solar, you name it. But the problem is they can't get the power into the grids, and it's actually more of a California bureaucracy issue. So I think it's not just about the private sector, it's actually the government's created so much red tape, and we don't have a shortage of this power, it's that we can't get it in. But one of the questions I had relating back to materials was, you had mentioned earlier around mycelium. I remember about 13 years ago being down in San Jose, and they were showing us, mycelium bricks and other things like that. What are your thoughts on these kinds of cultivated biomaterials? What do you see as the shortcomings? Why aren't we seeing more of that, or is there a future for it?
Similar problem as low carbon concrete. It ends up requiring essentially a whole chemistry lab, or in this case a biocultivation lab, to actually operate. I have seen probably a dozen mycelium concrete companies come and go over the last 10 years. It's one of those technologies I often worry about if the amount of resources going towards it is distracting from something else. But I've worked too much with biotech companies over the last few years to genuinely hold that view. This can be a solved problem. It's just a question of really trying to engineer the circumstances at which you are able to cultivate mycelium at scale in a way that can be exported at large without a lot of problems. It's really one of those things to where I shouldn't talk about it any more than I have, because I am myself not an actual bioscientist. I just tell them how to run their businesses well. So I'm just going to leave it at that. But this is something that could work. We're just not quite there yet. How are we doing on, John, how are we doing on time?
So we talked about construction, but what is your view on existing buildings? Because, construction can only do so much. I mean, most of the world is already constructed. And what's the energy implications of that? I've heard about 40% of emissions in the US comes from buildings today.
Well, there's already, John could probably talk about this a little bit with the things you guys are doing with the direct carbon capture that is already going on. But a lot can be done with, the efficiency argument, I feel, has kind of fallen on its face. Trying to solve the problem on an individual case-by-case basis is not quite working out to the degree that we want. We really need to start looking at new technologies to be able to make buildings less of an energy sink wherever possible. Probably the single biggest thing that could do that would actually be improving the efficiency of heat insulation in windows. If we are able to just reduce the overall use of heating and cooling in the summer, that will make all the difference in the world. Other applications are just generally more efficient appliances. But again, the problem with that solution is that you are taking a massive social problem that connects across an entire supply chain, and you're trying to make it a solution that individuals have to solve on their own. We've tried that. It hasn't really worked out all that well. So this is something where governments have to be a lot more proactive of trying to not just encourage new adoption, but reducing the barriers and really the financial burden to adopt new technologies. Probably the best example of this, I am aware that it's causing problems for the electrical grid, has been California and the country at large really pushing hard to make it easier for individual homeowners to swap out a lot of their gas burning stoves, heating elements and whatnot for something that is more electrically driven. That's a good step in the right direction. Hopefully that model will bear fruit and could be used across a whole host of other applications.
Great. Thank you so much, Keegan. Appreciate all the thought that you put into this, all the preparation, and for coming all the way from Seattle here. So appreciate that. Thank you so much. Next up, we'll have a panel discussion led by Andra. I want to quickly introduce Andra Keay to you. I've known Andra for 4 years. Actually, we put together an event at that time 4 years ago. This is just before COVID, and we were talking about how to use AI to fight COVID. And here we are 4 years later. I just met up with her like, I don't know, 4 months ago, and we just were casually chatting. Maybe we should do something together again. And that gave birth to this event. We both are passionate about, hard tech and deep tech, as well as making a positive impact. So I've enjoyed working with Andra to put this event together. Andra Keay is the managing director of Silicon Valley Robotics, robotic startup accelerator. As you probably know, Silicon Valley is home to the world's largest robotics and AI cluster with over 600 robotics companies and 50 robotics and AI research labs. And Andra is like an ecosystem builder who is connecting the dots. She's also the VP of Global Robotics for AMT, the Association for Manufacturing Technologies, as well as VP of Industrial Activities for IEEE, Robotics and Automation Society, and IEEE Entrepreneurship. I don't know how she finds time for all this, but it's been a pleasure to work with Andra. Let's welcome Andra.
Well, it's certainly been a great pleasure reconnecting with John and the entire team at Synapse, who, believe me, this has just been a wonderful event. I'm looking forward to it, the rest of it, but I have to take my hats off to what a great job our hosts and organizers have done. And I think everybody that enjoyed those little desserts will agree with me that this was a very, very nice event. And yeah, I was captivated by Keegan's talk. I've heard him speak before, and I was really looking forward to his insight, and that he managed to condense his insights into such a short talk when it covers so much is pretty stunning. I know Saul Griffith, who was the founder of Other Lab, and he put forward the Rewiring America platform. He's moved to Australia since then, where he's put forward the Rewiring Australia. And while it made me feel happy on the one hand that we could solve all our climate issues if every person had solar power, an electric vehicle, and a heat pump, I also don't agree that it should be the onus on the individuals when there is so much that both governments at federal and state levels and corporations can do. You know, I think we need to be sharing this responsibility, and some of the issues can't be, individuals cannot have the impact that is necessary on some of these issues. I have chosen Silicon Valley Robotics to really devote my attention to, because I believe that this is an emerging technology where we have the opportunity to guide the direction that the technology is going to take at scale. So the work that we can do with a startup as it scales can change the course of our technological development in general. It's that small, whether it's chaos theory and the butterfly wings, or whether it's the give me a level long enough and I can move the world point, finding that fulcrum, finding the point of leverage. And my goal with Silicon Valley Robotics is to support sustainable robotics companies. And what exactly does that mean? I've got some wonderful panelists who are going to dive in deep with this. And we've had a few discussions, like what exactly are we talking about when we talk about sustainable robotics? I certainly know that some of the researchers that I work with at IEEE have a very research-oriented direction of what the sustainable robots are. So I threw together, and I'm going to keep working on this, it's work in progress, not perfect, 5 levels of sustainability for the development of robotics, somewhat similar to the 5 levels of autonomy, also flawed. So level 1, which is what most people think about and that's let us use robots for an application, recycling. And in this instance, it's an efficiency play. We're simply putting robots in to augment something that people have already been doing. And that is often where we stop thinking about what sustainable robotics is. So I say this is level 1, and I love it, but it's just level 1. And then we have level 2, which is developing processes that people haven't been able to do, using robots to create new sustainable practices. And I think Urban Machines, and Andrew Gillies from Urban Machines is one of the panelists, is an example of that, because recycling old construction timber was not done previously. Or maybe it was done in the 1400s and 1500s for sure, but people were cheap then, and we were not using anywhere near the scale of timber. Andrew will explain a little bit more about this, but I think it's exciting to see robotics opening new opportunities. And we see this in the agricultural space as well. For example, small autonomous tractors utilize a lot less, don't have the same turning circle problem that large heavy equipment has. And almost 20 to 25% of fields are not utilized because large heavy equipment can't get into the corners. And in fact, if you've got center pivot agriculture, you have circular fields. So we've run out of arable land, but we have nowhere else to expand because cities are expanding and they are expanding into arable land. So without burning down any more rainforests, to get more agricultural land for the production of food, which needs to double by 2050, how about we utilize that wasted 25% of existing arable land using smaller robots that don't have the same footprint problem that large personed or crude farm equipment has. So that's level 2. And extending on that, there's robots themselves as a more sustainable practice. So electric robots. And it occurs to me that almost all of the robots that are moving into scale deployments in the world in logistics are electric vehicles. So in many ways, robots are taking over from far less efficient practices. And so the robots themselves are more sustainable than what they are replacing. Plus, there is the issue of shortening the supply chain. Anytime we can remove the steps, and you could look at, for example, electric vehicles as being an example of shortening the supply chain, because you have far fewer pieces involved in the construction of an electric vehicle. So you have a less intensive or less consuming supply chain. Then there is the robots that are made more sustainably, and the most obvious example of this is the use of 3D printing, particularly the use of 3D printed materials that are recyclable plastics that can themselves be recycled. And of course, this isn't all of the robot yet. You still have wiring, you still have motors, but a large amount of robot construction today can be done through these more sustainable practices and materials. Now, soft robotics has long been a passion of mine, and it's introducing a very different material in the production of robotics than we have traditionally used. Traditionally, robots have been very electromechanical and hydraulic. It's metal, it's welding, it's iron, it's oil, it's Boston Dynamics, combustion engines as opposed to electric. But when you're moving into, say, soft robotics, we're talking about a very, very different set of materials. And going beyond that, we start to talk about some of these materials, the soft robotics, are materials that can heal themselves or repair themselves. And we look at a whole range of research robots, and this is research robots at the moment, but we have seen these in successful research deployments: swarm robotics, self-assembling robotics, and self-repairing robots. So I'm excited about where the future goes if we're enabling a generation of sustainable robotics researchers. As we certainly see in Europe, this is becoming a very popular topic. And there are people researching this final, I didn't even give this a level because living robots, but there have been some use cases of developing robots out of cell cultures, for example, from frogs. And there's a lot that's happening in the use of biological materials as nanomachines for targeted drug delivery and cancer therapy. So it is possible that we can have a complete shift in the materials that our robots are made out of. But that might only work at very small scales, or it might still be the science fiction. But I just wanted to introduce these 5 levels of sustainability for robotics to give you a context for the discussion that we're about to have. And I would now like to introduce my panelists. And I think if I just turn that off and you're going to change the source. Beautiful. Now I need my glasses. Going alphabetically, Aidan, would you like to join us on stage? Aidan Madigan-Curtis is partner at Eclipse Ventures, a venture capital firm that invests very heavily in robotics companies, in companies disrupting old line industries. Aidan was also on the global operations team at Apple, where she was responsible for building the company's first SiP, system in package, manufacturing process and facility for the Apple Watch. And she was so successful that she was asked to lead the development of this practice in, to roll out this new manufacturing process across all the other Apple products. And that led to you also leaving for new opportunities at the early stage industrial IoT company called Samsara, where you worked on a whole range of global products, and then to Eclipse, where you get to see many more solutions, perhaps a little less hands-on, but a bigger chance to move the world, I guess, move the needle. Andrew, would you like to join us? Andrew Gillies co-founded an advanced robotics company to develop the solution to the enormous problem of lumber construction and demolition waste, as we mentioned with urban machines. Some of his other projects, he led the commercialization of a biomimetic robotics research project in origami circuits and imitation insects. And that was the toy robot, the Kamigami, that were produced, 2 successful Kickstarters, and then produced by major toy company worldwide, rollout. And in between, he's worked with other startups, being an advisor for agricultural robotics, and led a student team at Circuit Launch to build an open sourced humanoid robot. So a very varied approach, but very involved in both construction and agriculture after his experience with building a robot toy, which, by the way, really pioneered foldable electronics, and the only manufacturer that was capable of producing that toy, wasn't it, was the manufacturer of the Samsung foldable screens. So it was introducing, this was a case of robotics introducing a new manufacturing process. And I think that we should be seeing a lot more of that. It's an interesting field. I'd like to ask Anne Torres to come up. Anne is a Senior VP of Engineering in San Francisco, Managing Director of Synapse Product Development, and's got extensive work experience over multiple industries and positions. Most recently, prior to working at Synapse here, she was at Cooper Perkins as Chief Strategy Officer and VP of Engineering, the Director previously to that of Product Development at Polyera Corporation, where she was responsible for leading mechanical design teams. She's also worked at Apple, Function Engineering, SunPower Corporation, Mindtribe Product Engineering, Immersion Corporation, IDEO, and MIT CSAIL, with very varied roles in engineering, product development and management, and experience in industries from robotics to consumer electronics, biomedical, and solar energy. And finally, but not least, our Kira Noodleman is partner at B Partners, and I have to change pages because my lovely Samsung phone wouldn't let me continue editing a Google Doc. but it let me edit 3/4 of it, so I'm pretty pleased. This is the sort of thing that I wanted in terms of a working phone. And Kira is not just a partner at B Partners, she holds 5 board and advisor roles, including board observer at CIRCE, or Circe, is it the Circe? Okay. Board observer at Synthesis AI, board member at Future Fields, and she enjoys tackling problems in disruptive industries and across cultures. So one of the things that she's particularly focusing on, not just growing startups at the pre-seed stage, but looking at startups from a perspective of sustainability and what their impact on society is going to be. And that's robotics in synthetic biology and carbon tech, machine-to-machine communication, I think, as well. And you can, in fact, I think what I'm going to ask each of the panelists to do is to explain a little bit more about their background and what has brought them to this moment, this place, this time, where they're talking about sustainable robotics. And Kira, would you go first, please?
Sure. It's great to be here. Hi, everybody. And part of what got me passionate about climate and robotics was actually what I did before venture capital. So I was in software and a little bit of hardware product management. And one product I was working on was Google's Project Ara. And the vision was a modular smartphone. And essentially you could have reusable modules or components of the phone. And so therefore carbon reducing, you don't need to replace the phone as often. At the time, this is about 10 years ago. So it's also meant to bring the mobile internet to 6 billion people who didn't have it. And also what was really interesting about that experience was realizing it was meant to be this open hardware ecosystem that we don't have today. And so when I think about the opportunities that we're going to talk about startups and what's happening presently, so much of them do require these ecosystems that I think need to be built. So, and also actually around that same time, I had moved to Argentina and I'd chosen to be a vegetarian. So on a personal level, just because of some of what the earlier speaker was mentioning about the carbon impact of our food system. And so kind of on a personal and professional level, I've been really passionate about these topics.
Thanks very much, Kira. And alphabetically, going backwards, that would be Anne. Would you like to explain what brought you here to this moment today?
Yep, thanks. And yeah, thanks for everyone joining us. I'd say when I was in college, I did a lot of work in robotics, working in a research lab. And at the time, robotics was really a place for research and development. We're mostly doing robotics for other labs. And I turned my attention more into product development because that felt more impactful and I felt like I could serve my engineering and design could serve a broader range of people. Now you look and you see robotics everywhere, from robotics that are vacuum cleaners in your home to robotic systems in manufacturing and industrial settings. And so we see that robotics has become more ubiquitous than it was 2.5 decades ago. So that's gotten me very excited to see more of that. More recently, we know that now one of the biggest challenges that we have to tackle is really the climate crisis. And in order to solve these problems, we need to have really great solutions which are multidisciplinary and highly technical in nature. So I feel like robotic systems are a great place to help us scale and develop a lot of solutions that we need in order to solve this climate crisis that we have now, because robotics gives us this ability to do things more consistently, with more precision, with more reliability in places which are harsh and difficult to solve and do as individuals or human beings. And so that's the part of it that's really exciting to me. And this is where I see this intersection.
Thanks very much, Anne. Andrew?
Sure. Great to be here with this incredibly talented panel. My first exposure to robotics is coming up through grad school in Ron Fearing's lab at UC Berkeley. And it was a highly interdisciplinary lab. We had biologists, computer scientists, hardware engineers. I'm more on the hardware side. And just really ignited the possibilities that you get when you bring these different disciplines together. Went on to commercialize some of the technology we had developed in Ron's lab. That was my first startup, Dash Robotics. And that was an amazing experience. I guess I'm addicted to pain because I decided to start another hardware company after that. After Dash Robotics, really looking at where did I want to take this next, and where were there opportunities sort of with my skill set in the startup community. And sustainability is such a pressing issue that there's, I think, like a lot of us, a natural attraction to work on something there. And went through a few loops of experimenting with different ideas and exploring, these major industries like Keegan was pointing out. I think we kind of land within these pillars pretty quickly if you want to have a large impact, and started building a network in that direction. And that's how I met my current co-founder, Eric, who comes from the construction industry. And he had already done a lot of work in looking at sustainability in the supply chain at the construction firm he was at, and had scoped out the current problem that we're working on at Urban Machine right now. Which is how to recycle some of the waste construction materials, specifically lumber, which there's a lot of that we generate every single year. So that was about just about 2 years ago that we formed the company, and we've been full steam into that since then.
Thanks very much, Andrew. Aidan?
Great. Hey, hope I can live up to the amazing intros. Thank you, Andra. So I grew up on the side of a mountain in British Columbia, and I remember as a kid watching like the big bombers fly overhead to sort of drop water on the occasional wildfire that happened. And it's funny because, you look overhead when you see the forest fires happening now, and it's like the same technology. Like, come on. What are we doing right? We're not meant to solve these problems that we face today, whether they be natural disasters, prediction, mitigation, and response, whether it be toxic site remediation, whether it be bringing a much more advanced perspective, as Andra mentioned, some of these technologies to manufacturing, which is 30% of greenhouse gas emissions, given the incredible electricity draw and sort of complexity of these gargantuan, archaic old factories of the world, right, that still power how we make things today. We need technology, and we need full stack technology. We need atoms and bits, right? Going back to my fire analogy, it's kind of sad, actually. When I talk about the technology being like 60s, I mean like 1860s. Like, there's this picture that you can find online of firefighters putting out the Great Fire of London in 1861. And it's like the same dudes with hoses, spraying stuff that when you look up wildfire mitigation you see today. So we need all of you. We need the brains in this room, and we need to take a much more robust approach to actually tackle some of these challenges. It can't be done in the bit space alone. So that's why I'm here.
Well, Aidan's raised the applications for robotics in the sustainability field, and each of you've had experience both with starting your own companies, with investing in companies, with working on those companies. Would you each share examples of some of the sustainable robotics companies that you've worked with or run across? And Anne, would you like to lead off?
No, okay. Yeah, so I'm really excited. I think that there are so many places that we can see robotics in sustainability, and so I hope that we can share a lot of different examples. One that I would like to highlight is just a company that does helps with recycling. So uses robotics and AI to identify and improve how you can recycle. So it can improve 90%, 99%. So identify 99% of materials that should be recycled instead of going into the waste streams. I think this is incredibly important. So I think you use that as an example. And it's this way that you can see that robotics can improve what individuals can do and take it to the next level. We have so much that we need to get done. And this is one of those examples where bringing robotics into an industrial setting can help.
So these are some of the cases where having a worker shortage, as long as we introduce advanced automation, robotics, and AI rather than just machines, we have a chance of both solving for the worker shortage and improving the outcomes within the industry. I'm going to ask you all to come up with a company that you've seen that impresses you with work in sustainable applications, but also to think about what is an area that you think is ripe for development. And this is kind of seeding the discussion that you're all going to have as we do the breakout rooms, the round tables. And this is the sort of gathering that I love because you're all engaged and involved in these processes. And it's really important that it's not just some people talking and some people listening. This is a process that we want to have everybody engaged in contributing to. So just pick up some prompts. I'm a prompt engineer now. I'm putting it on my CV. So back to, what's a really great sustainable robotics company you've seen, Kira?
Yeah, I'll highlight one out of our portfolio. It's actually maybe 6 years ago. It was probably the first investment I was involved in. And it's called Interplant. And what it does is it makes plants into living sensors. So feels like sci-fi, right? And they recently raised a Series A. John Deere actually invested $30 million into this company. And so this is a really interdisciplinary project, much like what you were talking about at the UC Berkeley lab, where there's the biology side of it, of the genetic engineering of these different crops are focused on soy and corn. But essentially, this is large-scale farming going after those crops. This is meant to be for the biggest farmers in the world. And so where robotics comes into play is, when these plants are actually in fields, which is happening today, you need drones, you need, with John Deere as a partner, there's something called See and Spray. They have on the ground robotics. And so essentially you have a new data source with these plants that have been coded a certain way so they can detect when fungi is present and other types of conditions. And then you need all that hardware and robotics around it to pick up that data. And then what you're really trying to do, in essence, from a zoom out perspective, is build a system of intelligence and understand in a way more detailed way what's happening across, hundreds, thousands of acres of farmland. So that one's one of my favorites, really fun, climate robotics, bio, it's a ton of things.
That is super cool. I don't know that anyone's going to top that one, but Andrew, have a go.
Sure, we'll give it a shot here. Yeah, there's a lot of exciting. That's a great example. A lot of exciting precision agriculture applications. That was going to be one of my examples, but I'll pick another one. So a company that I've been following for a while, they just announced a product just a handful of months ago. They're called Built Robotics, and they're automating the process of building out industrial scale solar farms. And through automating that process, they're able to massively accelerate how quickly you can build out these solar sites with a sort of an automated tile driving system. And yeah, this is a great application where, like humans out in the field doing the construction is the bottleneck. And with the amount of solar that we are trying to install, it's going to just open the floodgates for what we can do there. So yeah, I find that a very exciting application.
That's very interesting. Aidan.
Yeah, super cool. And Built Robotics, their mandate is not only just the solar, but it's wind farms, it's all of construction. It's a super cool company. Okay, so this is like literally my job. So I'm just gonna throw out a bunch of these. Some in our portfolio, some not in our portfolio. I'll start with the not in our portfolio first. Amp Robotics is killing it. For $1 million bomb, they can produce millions of dollars of recyclable materials through the computer vision and the robotic systems that they have. They've actually got like a ton of installations. I think they're doing a great job, not only on the actual robotics themselves, but on the go-to-market, on building like a sustainable business, which is a big part of what's challenging in this space. There's a really cool company in the breakthrough energy portfolio called Comment. It's actually able to reduce the greenhouse gas emissions of the Portland cement process by 50%. By using more of an electrochemical plus robotics process versus the typical like burning a ton of coal essentially to create Portland cement. In our portfolio, we have a company called Reframe, which is a very small, like a micro factory for modular construction units. Like imagine you've got building blocks as Legos that you can build up a multifamily unit home. They do it in a totally net zero way. It's called Reframe. And that's very robotics heavy. It was actually one of the earliest guys at Keay, who was then in Amazon Robotics for like 11 years, who came out and worked with us to bring up Reframe. there's a ton of them. So happy to kind of keep talking. Maybe the last one that's worth mentioning is PFAS remediation. So PFAS, the forever chemical, carbon chains with a ton of fluorides on them. Our bodies can't break them down. They sort of just pile up in places like our pancreas and our liver, in breast milk. If you don't have a reverse osmosis filter, get one. They're super dangerous. The soil is basically highly contaminated with it. 1 in 6 Americans lives beside a Superfund site, in case you guys didn't know. And so there's the kind of tragedy of all of this is that there's actually no true remediation for PFAS. You just sort of, there's 3 ways of dealing with PFAS right now. One is called digging and hauling. You get the picture. It just goes into a landfill. The second is called capping. You put cement over it and kind of wait for the half-life to do its thing. Also not particularly effective because the issue is that it's leaching from the soil into the water supplies. And the third is called natural attenuation. Yeah, just like kind of hope it goes away. So we actually just funded a company that is taking a robotic approach, like a fully automated soil sampling and ball milling approach to PFAS full remediation. And it's really neat. And so I think it doesn't need to be like your typical thought on robotics to actually make a difference. There are a ton of applications for intelligent systems, which is kind of how I think about robots. So.
I quite agree. I think, as many of you know, the definition of a robot is something that doesn't work in demos. But what that means is it's a rolling definition. And what is a robot today is far more sophisticated than what was a robot 20 years ago, or indeed what was a robot 40 years ago, which we still have welding car assemblies, yet wouldn't be considered to be particularly perceptive or intelligent. So the definition of robotics rolls as we become more sophisticated in what we build. And one of the things that we often overlook is how it's the interconnection of data communication across a robotics device, or it is the intelligent system at work. So that's a really good point. And I'm going to continue this with a deep dive into the design and engineering side of building sustainable robotics. Is very frequently when you say, well, we want to use robots to address these problems, a lot of people have a problem with that initially. And it is on the idea of, well, you're just building more stuff, creating more waste, introducing more negative outcomes into the systems, or more negative outputs. Now, I personally don't necessarily believe that's the case, but how do you counter the argument that it's not going to be a negative attenuation or passive, natural attenuation process, that we're not just throwing robots at us as a solution that creates greater problems? In what ways do you see this as being qualitatively different? Any hands for this one? And you can.
Well, I think this is a place where whether you're building robots to help in climate change, with the climate change crisis, or you're building robots just to improve efficiencies, that you actually also have to think about the circularity and the design of these particular systems. It's absolutely important. We should be doing that. That should be part of all of our product development process. So starting to think, and when you think about circularity, what you're thinking about is what are the materials that are used? Where do they come from? What happens throughout the whole process of developing, building the system, all the way through the life and then the end of life of these products. So I think that that's an important piece of design that needs to be brought into robotics, not just everyday robotics, but robotics that are specifically being built to solve the climate crisis.
So if we looked at the typical kind of bill of materials for the average sort of robot system today, or large vehicle, really, large electric vehicle probably covers it, what is the most problematic component from a sustainability perspective?
I mean, there are a number of pieces here. You can, especially with large electrification, batteries, is a huge piece of it. All of the metals and materials that if you're coming from virgin materials that have never been used before, that is a big drain on our resources. Things like water, carbon emissions, either the carbon emissions that are inherent in all of the materials that you use, or once the product is in its operational life, everything that all of the energy that's drawn in. So robotics and robots can use as much energy as vehicles and cars. So these are things that are really important to remember. So when you think about circularity, you're thinking about the materials that you bring in, the energy that is being used, both to create it and at the end of use. And then you also think about things like data and what you're collecting and what impact that data is going to have, and the storage and use and the computation around that data. And then you also think about the money. And the reason you think about the money is because the money can also have social impacts. So when you're thinking about creating sustainable products, that circularity also should think about what are the social and justice related impacts of that particular product. So we want to be creating products that aren't just solving a problem, but are actually working in this whole ecosystem of having a sustainable planet, which considers the people on that planet.
Yeah, I +1 to Anne on the battery being a challenging component from like a circularity perspective. And I forgot to shout out Redwood Materials when I was talking about really neat full system approaches. Obviously, there's a lot of chemistry going on there too, but full system approaches to one of the biggest challenges in circularity of electric vehicles and other forms of storage going forward. I also think plastics are pretty problematic. Like we recycle 9% of the plastics we produce. We produce $600 billion worth of plastic, or $1 billion worth of plastic a year as a world. So it's a lot of plastic. I think it's like a Rhode Island 30 feet high of plastic a year that we produce out of virgin plastic or something. It's a lot. So the more we can chip away at that one, and that's why I was excited earlier about AMP. It's just one company, but I think they've got the right full system approach to helping our MRFs, our materials recycling facilities out. The other thing I'd say to respond to your question, Andra, is I do think there's a huge risk of like robots for robots' sake, or like technology for technology's sake. At Eclipse, we always start with what is the like economic problem that you're trying to solve. And by economic, I don't mean big picture economic. I mean like what company's specific pain are you going to resolve with this solution that you've created? And we work backwards from there. And what you really want to see, what we want to see when we make an investment, is how bringing a modern technology approach to solving a very specific issue that is budgeted, that you can actually go in and create a solution for, provides like a 10x better outcome. And to Anne's point, like when you create better economic outcomes for the players involved, that can sort of create greater overall efficiencies. So that's how we think about it.
And just to chime in there, I completely agree on, what problem are you after? What are the markets that, really are there for the taking? And I think in general, if I zoomed out to what deep tech investors look at, it's often the opportunity is if you're primarily taking a tech risk, but the idea is if you take the right tech risk, once you de-risk that technology and it gets to some meaningful scale, the markets are there. So you might go from 0 revenue to 9 figures in revenue. I've seen those examples play out. So just completely agree. These are about problems. That's business is about people. And to tag on to just robots and are we building them, or what's exciting on my side, I like the idea of batteries for sure, recycling there, but also just more categories of what we can recycle. And so another example is complex electronic systems. And I've got a startup example, and then I've got, what the biggest incumbent out there, Apple, does. And so I think, to start with, say, Apple here, I think it's 20% recycled product is in a lot of recycled materials in most of their products. And they have this a machine called Daisy that I guess can disassemble an iPhone in 18 seconds and give you all your valuable materials like gold and cobalt and so on. And so that's incredible. Technically speaking, we can do that. And an example of a startup I've seen is called Mold, and they're essentially a microfactory and they want to assemble and disassemble electronics, starting with PCs and servers. And so thinking about it, it's one thing for an incumbent to do it, but for a startup perspective, I think what's really interesting is it kind of forces this question when we talk about circularity of like the business model here. And so I think what comes up is, if you're going to have these products that extend into longer lives, you need, well, how are you monetizing that? If you're a business, you need fleet management, and you need like a lot of efficiencies that essentially. Right now, I don't think the incentives are always there for them. So hope to see more of those examples, and I think Apple's a really nice beacon as to what it could look like.
Those are excellent points. And robotics has coasted, well, let's say benefited. A phrase that I've heard tossed around is that robots are the dividends of the smartphone and the games console wars in the miniaturization of computation and the electronics around that has allowed robotics to really get to the level that it is currently today. Now, robots that can operate faster, think better in smaller packages, make it easier for the battery power, but we're really not seeing the sort of Moore's law level of improvements in the battery scale technology. So battery life is perhaps one of the biggest problems. Now, you can have small robots in some areas of agriculture, but in others you need large machines, ditto in construction. So you're still going to need a real step change in the battery production to have a significant impact there. One of the things that you've both brought up the business value. In fact, you've all brought up the business and the value proposition creating. One other area is how do you calculate? A lot of these companies are creating, they're category creators. They're introducing a new solution altogether. How do you go about calculating the value of what they're bringing? It's not as simple as saying, let's put this robot in and it's going to replace this labor cost or this capital cost. It's going to open up and potentially with the data, unlock completely new opportunities. So how do you go about calculating what the actual value proposition is?
Yeah, maybe I can jump in on how we've approached this at Urban Machine. We sort of think about it as like introducing a new system template into an existing system, right? So it's like the first, sort of first step in that journey for us is like, what are your connections into the existing system, right? And that kind of starts to define the contours of the inputs and outputs around what we're doing. So at least you have some like borders or some boundary conditions that you can deal with, right? And then from there, it's sort of like filling in the dots through what you anticipate your process is going to look like. And, at first, early in the development process, it's pretty rough. It's very back of the envelope. And one thing that I like to say is that at those early stages, the back of the envelope math should be pretty clear that this is going to work. It should be a slam dunk, actually, at those early phases, because you're usually only going to get your situation is only going to get harder as you go forward, right? It's only going to get more burdensome. And once you start building things, guaranteed that back of the envelope math is going to get degraded so much. So it's really just about like doing the early work and then iterating on that as you learn more, as you're prototyping, as you're doing your early pilots, learning that model and refining that model and just like adding more nuance there. And just like, yeah, respecting the boundary conditions really, and just being focused on that. Not just on like how much can the robot perform or what does the robot cost? Because there's those other considerations from like fleet management, operational scaling, like the cost of building out manufacturing, all of that is just going to weigh down that initial model.
Yeah, I'll jump in. There's a couple of different ways to look at it, at least from our perspective. So let me give you manufacturing, like as a very tangible use case. You ever try and sell new technology to a manufacturer? Yeah, good luck, right? So it's quite interesting. We have a system that does 3D metal additive. They can produce a lot of different types of parts. And yeah, at first the concept was let's go to market selling this into traditional manufacturing. We realized relatively quickly that if we actually, first of all, you kind of take a step back and say, like, where is the greatest share of wallet, right? Is it selling into rather archaic, like metal fabrication in the US? Or is it actually producing novel parts for, the largest defense primes or, people who are trying to create hip implants that, couldn't otherwise be created based on shape and form? And can we do it in a way that uses less energy and is far less carbon intensive? Yeah, in this particular approach, right? So we realized that from like a, how do you evaluate the value? And these are hypothetical numbers, that $1 million piece of equipment could produce, let's call it $15 to $18 million a year of revenue, just by actually fully vertically integrating in some sense and being the manufacturer ourselves. So that's not applicable to every use case, but I do think, it's not only about kind of what kind of business value can I generate selling into an existing system. You can also try and look at it through a completely different prism and actually capture the value of your technology yourself. And it's really, it is meritorious to take a look at that, especially when selling into some really archaic industries like the ones a lot of us deal with.
I have seen that in practice from a range of startups that I've worked with in the last 12 odd years. They've gone from wanting to sell into an industry to, often with the investor's advice, to creating their own factory as a service for a specific process. Carry on, Anne.
I want to just also kind of touch on this. I think what Aidan said, something about robotics for robotics' sake. I think also sustainable robotics for sustainability's sake. I think one thing to remember is in the end, it's about money. It's about, that's what is going to make a business successful. I think there are a lot of incentives now with the IRA, which is incredible. It's giving us a boost and this ability to get money and investment through government incentives in order to help us try to build new technologies and new products to help us reach our net zero goals, to decarbonize, to remove carbon from the air. But also in the end, the companies that we build and the systems that we create need to make money. And I think that that's one of the things to think about in terms of when you're trying to build these systems. So I'll just go back to that recycling robot. So if that technology is deployed, more widely, it can save something like $200 billion in diverted recycled materials from the landfill. We all like to recycle. It's really cool. It's going to help, help us be more sustainable. But that dollar amount is not insignificant. And the importance of that is we need sustainable solutions to scale quickly. And things scale quickly when there's money associated with the solutions that we're creating. So just want to iterate that fact that it's not robotics for robotics' sake or sustainability for sustainability's sake. We're going to be able to scale when there are real business needs and values that we are solving, and the result is going to be money back.
And just to tag on to that, because I think it's a really great point, just a couple other demand signals that I think are pretty exciting and paired with the IRA, and I think it's a tax credit, $3 a kilogram for green hydrogen. But beyond that, just some like what's happening in the corporate world today. So there's the First Movers Coalition that have dedicated or committed $12 billion to net zero products, and it's across all kinds of industries. So high level statement, but that's the dollar amount. And there's a different, just some of these really large incumbents, like one of the biggest steel companies, it's somebody's name, so I'm forgetting what it is exactly, but they just recently invested in a green steel company for $120 million. And so I think what's exciting to me right now is I do think money moves things, and I also think a lot of people with a lot of money are paying attention.
That is very hopeful, because I think all of us in robotics know that it is very hard to get hardware funded. I don't think it's necessarily hard to build hardware compared to software, because enterprise software is a cow, but it is hard to get funded to build robotics. So we need to maximize how rapidly we can scale and grow on the smell of an oily or perhaps electric fluid rag. But looking at that, and just before we open it for questions, so I want to ask one more question around cutting costs, perhaps, looking at the bill of materials around the materials that go into this. And I've just throwing this question in because of an article I saw yesterday. A colleague of mine in New York, Wendy Jew, and her colleague have just put out a paper talking about arbitrage, talking about how cheap it is, comparatively speaking, to get hoverboards compared to the cost of getting the bill of materials of those hoverboards here in the United States to build your own robot project. So they were running their project going around and reclaiming waste hoverboards, scooter boards and so forth, and then stripping them out to reuse the components. And they were talking about, you know, there are other technologies that you can do this, things that have become a very popular consumer product that still have a lot of, I remember when it was building 3D printers using old printers, not 3D printers, but just printers. If anyone remembers those, it's a long time ago, but never mind. So where are the opportunities for us to perhaps recycle consumer devices for bill of material items, or to cut costs in the BOM of what we're building now?
That's so much fun. Arbitrage. I love that. We don't make anything here, like when it comes to any form of electronics. So that's a tough one. I mean, all the way down to the batteries, right? Things are largely made elsewhere for the most part in Asia and shipped over here. Obviously, Mexico is kind of pulling up in terms of production. So I can imagine that there's opportunities across the board there, but pun intended. I'd have to give some thought to it. I agree with the commentary on the IRA really helping us leapfrog a little bit on things like onshoring fundamentals of battery cell manufacturing, which are highly capitally intensive and unfriendly. So there are chances going forward, but those projects are going to take half decades to decades to really make a meaningful impact. Like, I'll probably ask to like circle back at the end of this row of people answering this question because I want to put some thought into it. But I really do think we have a big, big problem. Hopefully that's why some of you are here in the room, because you're trying to figure out where, you know, which parts of the board, which parts of the system to attack first. I think there's $20, $100 bills on the ground everywhere because we really don't do anything here. So come back to me on it.
I can just bounce off of that with some of our experience in developing our system. Our system is quite large. It's you know, like ends up being like at the end of the day, several modules. It's about a 80-foot long processing line. There's a lot of welded steel structures, which aren't going to be commodified in China anytime soon. And our local supply chain, welding labor is a huge bottleneck for us. And I'm really excited to see, and we speak to our suppliers about that, about seeing some amount of automation in welding of steel structures to help, you know, and that could help on a variety of vectors across, like building large structures, large automation platforms. So that's one area that's a pain point for us, that you could see lower costs and easing of the supply chain around that. The other one is around sort of the oft peaked in control cabinets that you see around automation systems, which are usually some like combination of programmable logic controllers and other electronics devices that are mostly universally hand wired by electricians or box builders. And it's also a huge bottleneck. There's a lot of componentry that goes in there. Some of the automation suppliers are starting to go towards boxless designs. Like Beckhoff, for example, is launching new boxless design products, but we're just really at the beginning phases of that. And that's another huge bottleneck. A lot of labor goes into that, a lot of cost. There's also a lot of components in there that are not currently recyclable. The same reasons that, you know, electronics are hard to recycle. So I think there's opportunity there to sort of collapse some of the things going into the control cabinets around automation systems.
That's very insightful. And Kira?
Yeah, I think one answer is pretty straightforward that I've got, which is just seeing more companies working with commoditized hardware that's just available now on the market. You know, one of our companies was busy building this robotic arm and poked their head up and realized there's a lot off the shelf, and we can actually instead focus on kind of the software that makes these robotic arms more flexible in the tasks that they do. And so I think flexibility on what these robots can do, and that software powered, that's really CapEx light, you know, those are really interesting solutions. And taking it maybe a really different direction, one of our companies, it's a bioplastics company, very much identify with the challenge with plastic. Another fact is by 2050, we're supposed to have more plastic than fish in the ocean. Terrifying. And so the concept of bioplastics and a biomaterial that literally the way they make these plastics, it's materials from a garden and it composts. And so, you know, having plastic in so many things that we manufacture and having it be, you know, maybe not free, but very low cost would be pretty exciting.
Yeah, I love that example. I like the word garbageage, but I also wonder, you know, when we design products, can we think about this idea of garbage or what happens at the end and get rid of, like, think about how do we get rid of that completely? How at the end of life do we make a product that doesn't ever really have an end of life? So I think that this is where circularity comes in from the beginning. So yes, we've produced all of this stuff and we should think about everything that we've already produced and how we can reuse it, but everything that we're going to produce in the future, how do we keep using and reusing it, and what does that look like? And especially in robotics, we know that these systems are complex. There are parts of these systems that that change and iterate quickly compared to the rest of it, right? There's a lot of capital that goes into robotic systems, but some sensors or some microchips or motors might have very quick revs, and they're very expensive, both from a cost perspective, but also from a materials perspective. Can we make those easy to replace? Can we think about how they might be used in other areas? Can we think about, after we've created these systems, either full systems or subsystems, how they might be reused in the future? And there are lots of great examples of companies who are building computers and phones who are thinking about that. This is the kind of thing that, you know, starting from the beginning, starting from the concept is really important for us to think about.
Just a quick comment relative to that. Since as a pre-seed investor, I invest in two founders and their vision. Something we've been talking about as a theme is design for reuse, or DFR, where in manufacturing, there's things like design for manufacturing, thinking about scale, but really introducing that concept at ground zero for, you know, in the DNA at that stage, for us is really exciting, of, you know, essentially ensuring this is going to be in the vision of the entire company.
The last thing I'll say is, I think, Andra, you said, should we put this on consumers to be the ones who, like, put the bottle in the right place or think about how to reuse? I think this is also a place for us as developers, as companies, to take more responsibility for the things that we're creating, because we know that what we create has an extremely big impact, more than us as individuals stopping to fly or flying less or driving electric cars. That as designers, the work that we do can scale very large. And so the impact of what we create can be very large on the earth. So thinking about those things and taking responsibility, I think, is an important thing for us.
So my real answer to this question, to add on to everything you guys are saying, two things. One, I think you asked the question in the hopes that people could get some, like, tangible take home about how to make a cheaper bomb, in which case I think a lot of these points were great. And I will say, before we had the beautiful word circularity, we just called it refurbishment, and we refurbed all day, right? Send me back your stuff. You want to upgrade to the latest model? Great. Can't wait to take the board back, take the old casing off and slap something fancy on and send it to the next guy, right? Like, it's a great process. It's both good for the world and it's good for your bottom line. So refurb all day. 2 thumbs up. And then the other thing that I would say that's far less tangible or helpful probably to anyone in the room, but is definitely like very interesting in terms of where structurally our costs are upside down, is around labor. So while on the one hand, I very much believe in, you know, Americans having jobs, I am excited for a future where our work can be fun and engaging and technical and interesting, less dangerous, potentially less hands-on. There's a lot of work that people just don't want to do these days, which resonates. It's tough, it's hard, it's loud, it's smelly. Let's get greater automation onto manufacturing lines. Let's, you know, sort of inspire people in the room here to go solve these problems, because we have 4 million jobs in the US that literally no one wants to do or is qualified to do. It would be great to bring like semiconductor manufacturing back to the US. Intel can't get its fab made in Arizona because it's like 8,000 laborers short, not like semiconductor engineers, like electricians and like plumbers. You can't get the fabs built. So we need other approaches to this, and hopefully people in the room will have some solutions.
Yes, that's really hitting some of the deep problems. And on that, let's have some questions from people in the room, and maybe not about the big social issues, maybe about the BOM costs, or maybe about the investment theses that can include these issues around sustainability, or maybe about your experience in growing a company in another application area for sustainability that we haven't covered yet. And I see a hand up and just behind, yes.
Well, one of the most interesting topics brought up early in this was the idea of automation in agriculture in terms of data acquisition using plants themselves of that. And that blew my mind, because I immediately thought, well, when we talk about automation, there's one phrase we haven't said in this room so far, I think the whole time, and that was digital twinning. If we can automate agriculture to such a degree, what do you think the limits of predictability in ag systems to be able to get a better understanding of how farm science works? How far do you think we can push that, at least in the near term, using technology like that?
Yeah, I mean, it's a great question. I think what's tricky is until we have more data and we see how consistent everything is, it's kind of hard to answer. But and also, I guess let's factor in how the climate's changing pretty wildly every week. So I wish I had a better answer, but I will say, as a comparison, you know, it's kind of like we have generic kind of a blob of data of how, you know, acres operate, and we're trying to get to a plant by plant basis. So at least there's a comp in the background, or historically speaking. But I think, to me, what's interesting about your question is the variation across these fields. I mean, that's really what we're getting after. And then what's really the point of the data and the value there is you can all kinds of reduction of inputs into those fields. And maybe just one other point is interesting is something I've learned about ag tech is that actually farmers are not as much concerned about increasing yields and selling more. They're actually risk averse, and it's more like what happens in the down years, and are we going to be able to stay alive, basically. So whatever that data shows, I think that's what the farmers are going to care about.
Yes, following on from that, in terms of data, IEEE has got a standards working group together on data standards for agriculture. And it's one thing to talk about the increased opportunities to collect data, but making it interoperable and making it useful, that's another thing altogether. So if anybody's interested in getting involved in that standard, please reach out to me. I think there was another question there. Sarah, or perhaps a comment on that in agriculture. Sorry.
I had a quick comment right before we move on to the next question around ag tech. So there's obviously outdoor farming, but I do think that there's also some indoor farming applications as well. We've at Synapse, we've done indoor help companies do indoor automated agricultural farming, and I do think that the digital twin can help there. We've also started to talk about this idea of micro farms. So one of the challenges is that we grow food in places that are very far away from where the food is actually eaten. So if you can have micro farms sit in urban areas that are close, or even where it's being used in restaurants. I think that that's also a very interesting application for what ag tech can look like. And I do think that collecting data in these areas could help, because an individual like a cafe might not be great at growing their own food, but if they can have data from other people who've done something similar, I think this could be a new or interesting application of that technology.
Can you hear me?
Yes.
I'm the former senior vice president of engineering at Ironox, which was a indoor farming company. And I was talking to Lee about data in agriculture because we're really interested. And so we talked about sustainability for sustainability's sake and robots for robots' sake. I just want to call out data for data's sake. I think you really need, especially in agriculture, it's clear they have a data problem, but data is actually an arbitrage for a lot of these players. And they don't want their data shared, and they don't want it in the hands of other people. And you could run a risk of actually being a startup that sells to startups, which is not always the best way to go. And so I think when you're looking at data, I'm a machine learning PhD. I love data, and it's so attractive, but really understanding how all the money flows and the capital up front to make your business work makes ag really hard. And happy to answer questions about that ride if anyone wants to talk later.
Yes, that's why I did want to bring Sarah into that discussion, knowing her background in agriculture and data. Are there any more comments on agriculture? I know there were some other questions, and I didn't want to cut people off. Yeah, Kira has one more thing to say.
Throw
yes.
one more comment in, which is when we talk about agriculture, what's happening in synthetic biology and the future of food is really bringing agriculture into the lab. And so talking about data and how the whole system works, it's a totally dramatic difference and a totally different world. The data there is lab automation, how efficient the microbe is digesting the sugar to produce the protein. Today, it's all about scale up and getting to scale, which is the equivalent of acres and acres of farms. So I think that's, when I think about ag, I can't not think about SynBioFood.
Brilliant. Your question, sorry.
So the one word I keep hearing, build, 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 and build. And I think we're in a room full of builders here. And I think though it's important sometimes for us to think about what we're building, why we're building it, how we're building it. And instead of building, because if you think about it, we're especially in the world of robotics, right? We're talking about hard, dead materials that we're taking and transforming, whether it's into, an arm, whether it's a motor, whatever. But I can't help but think, and I'd like to think, Kara, you kind of stirred up this little light bulb. You reminded me of something from 25 years ago that I was involved with, which is thinking about integration and where we can develop symbiosis. Because I think we're always looking at electrical, battery, but I feel like if we really want to solve these problems, electricity, there's cost behind that. Batteries, there's cost behind that. There's a lot, but there's all these biosystems that we can build, we can integrate into that we could potentially build, robotics solutions, not using the existing power systems that we're using, not using the same fuel systems, not using the same materials, which are both naturally regenerative, which don't do damage to the planet, which don't generate all this excess heat, et cetera, et cetera. And I was very curious, like, what are some of the things that you guys are seeing out there? Like, I remember, 23 years ago, looking at, generating electricity off of bacteria. I mean, there's so many other technologies, so many other ways. The power density on batteries just isn't there. And if we're really going to push forward and replace things, I just can't help but wonder, what are the materials you guys are seeing? What are the other things where we have opportunities for symbiosis? Like, I know MIT does a lot on like cyborg botany, but there's also thousands of years of old knowledge out there. Like, for example, like we know that certain plants will tell us signals. So if we can just have our robots use machine vision to look and say, oh, hey, this is what's telling us this is happening in this environment. We don't have to build and put new things out there, right? So what are you guys seeing? What do you guys feel is promising?
I'll start with one idea, and I bet this panel has some interesting thoughts, but another example that's really exciting to me is a theme we call carbon to value, and there's a company, Circe, which is named after a Greek goddess, and it's all about taking enabling gas fermentation and using carbon as a feedstock. And so essentially it's the possibility of negative carbon foods down the line. That's probably time. Could say more, but
It's that folding phone. I don't know.
Well, I just have unresponsive fingers. No, I think your question was very interesting, and that reflection, you know, the inspiration from what Kira was talking about with Interplan and what you're talking about with Cersei, there's a lot that's happening in the research space, but very little that is coming to the scale that has an impact right now. Barring, I will say that there are some moves in battery technology. A company I saw at CES 2 years ago is now producing at scale a carbon battery, utilizing the existing battery factories so it can scale really quickly. It's only one anode that is pure carbon rather than rare materials, and yet they're planning by 2025 to be producing the full carbon battery. So you've got a completely natural material replacing the rare materials with the same output power, and it looks like they're actually commercial and going to scale.
Andra,
So
I was gonna say, actually, I thought maybe battery chemistry was like kind of off limits because it's not so much with the robots. But yeah, we actually just invested in a sodium-ion battery, which is sodium and iron, right? And to the point of like working with materials that are abundant in our, you know, whether it's within our national borders or just sort of easier to get, harder to produce, less chemically intensive to produce. I think there's something there too. And yeah, battery chemistry, given the energy transition we're under, is huge.
yeah, I am having a bit of scope creep, but you can't really be excited about the future without being excited about advanced materials. And that to me is one of the most significant things that we're getting from AI at the moment, is this increased computational ability to work with, to predict, and to tackle new combinations that can have eventual impact on our entire way of creating machinery. I think that the overall replacing the electromechanical systems with the living machines, even though I have built a robot with feathers and with grass, but it doesn't reproduce. So, you know, forget that. I will say one of the comments from this panel, and I'm sure there's more questions, but the comment about having a not just refurbished robots are a big business in the US, and I didn't realize, but many small, medium enterprises are purchasing off the secondhand ones that the large companies, the secondhand robots that large companies are no longer using. And I have browsed through some of the resale sites, and there are quite a number of older robots out there. And that is often a company's first dip into the field. But the idea has often been described, we cannot have long life products because our consumer economy will not let us have long lasting repairable products. But as they increasingly become data plays, which was something that the panel have brought up, then I think it does open the door for us to have evergreen, you know, circular or non-dying physical products, because the actual money is in the data. And the point that Sarah raised is the negative side of that, that is the carefully fought over battlefield for investors and for companies. So that's the forces that we're working against when it comes to the dream of having long life products that deliver great value to people, is who owns the data. So do we have any more questions if we've still got time, John? Yes, there's Rajesh has got a question, and yes, one.
Can I just say something really quick about the data piece? I think one other related I think topic in this area is also to think about products are important, but maybe products as delivering a service. So a good example is a company called Mill that does a composting system, that they're delivering the service of composting, and then what comes out of that, they're also collecting that and using it as as chicken feed, and they'll eventually have it be compost. But the hardware piece they own. Similar to your Whoop. The idea is that the hardware is kind of secondary to the value that you get out of the service of the piece of hardware. And in the mill case, and that means that they can take it and refurbish it. They are responsible for that piece of hardware and deploying it in different areas and having it work within whatever the ecosystem of that municipality is. So those are kinds of things that we can think about as well. It's like a shift in what our relationship is to the hardware products that we're creating or that we're giving as an end use product.
Excellent. Juan.
Okay, Kira, were you gonna say something? Or?
No worries. Quick comment related to what you just shared. I know the case of AMP Robotics, which is computer vision for sorting of recyclables. You know, the ROI of the robot was step one, and this is, I think, their Series B, or at least Series B, if not Series C, so way past to go to market. But really what the play for them has become is about data, and it's about efficiency of the entire operation. And recycling is actually 5% of what the waste management play really is. So I found that illuminating, and I think it just goes back to data.
Great. So what a great panel. Thanks for putting this together, Andra and John. And really sympathize with what you said, Andrew, of a lot of time is put into wiring control cabinets. This was by far one of the previous companies have been the biggest amount of time. And also, it's so unfortunate that I just founded a company and now there are like so many ideas. And I kind of, okay, I already picked my winner, but okay. But trying to stick into manufacturing. I truly believe that bringing and reshoring manufacturing and nearshoring will have a huge impact, given also that China is #1 contributing in polluting, and doesn't make any sense to, I don't know, send, for example, fish to China for the skinning and then bring it back, right? Given that, and also the fact that all these net zero targets that some of the companies have, and even the government, right, by 2050, which seems very far away, I don't know when they are gonna push it and nobody will remember. But do you think, to your point, Aidan, too, that manufacturers have a hard time adopting technology, right? Even if there is a new way to do IMM in a much more energy efficient ways, they're going to push back. Do you think that will move the needle, having this kind of net 30 goals by, because usually they are suppliers too, right? So if I am selling to BMW says, you have to be net 30, or I don't buy from you. Do you think that is going to move the needle, or is mostly at this point in time marketing?
Hey, Ron, good to see you. No, I don't think it matters. Sadly, call me the pessimist. I have a couple companies that, a couple that we built and some that we invested in that were really centered around circularity targets for 2030 and carbon management targets for 2030. Like if you look at Ellen MacArthur Foundation, she's done an incredible job of gathering some of the world's top emitters, like extremely prominent brands across CPG, across kind of all major categories, oil and gas, to commit. And it's just sort of like people are just failing colossally, like en masse together. And what it sort of feels to me is that if like everyone else is kind of failing, then no one's really going to get targeted with it. So I think that the way this changes is unfortunately somewhat slowly over time. It has to do with how the people act, like how consumers think and what kind of pressure we put on companies, which is a slow battle of hearts and minds. And it also has to do with regulation. Obviously, regulation has to do with how people think and how they vote, and it's iterative and so on and so forth. So I don't think that some of these targets I don't think these targets are going to be achieved. And I don't see the connection between the large C-level commitments into the organizations, into procurement, into manufacturing. They're not goaling the companies, the leadership differently. No one has a bonus tied to certain circularity targets. Like it has been a slog, and I don't see it manifesting. So that's the negative side. Someone's make the positive side.
Yes, sorry, Johan.
I could add to your point.
I'm going to do my best to distribute over regions and kind of cue people up mentally.
Now?
So just a really quick one. So I know here in Silicon Valley, like we tend to we pride ourselves on being on the cutting edge of innovation, but I think there's always a danger sometimes in the echo chamber that we create here, and we sometimes miss a lot of big opportunities. And one thing I would have to say is that it depends what market you're looking at. And when you deal with VCs in the US, one problem is they tend to be very myopic and they're not very global. They tend to think just about the US market. But if you go to certain parts of the world, there is a lot of opportunity. So for example, in Europe, companies are, over the next several years, mandatory going to be required to purchase a certain amount of carbon credits or show that they are reducing. So if you look at, let's look at a company here in California, Tesla. They didn't make their money off of selling their cars. They made their money off of selling the credits. So there are business models there. You just have to consider what market you're in, what are the regulatory environments that you're dealing with, and you'd be surprised. There are massive, massive opportunities. And I would say, look at Europe, especially huge opportunities in Spain and other parts of the, the European continent where this is really being pushed hard.
Well, that is really good to know. And I think that we will hope to see that ripple through, particularly knowing the track that the Department of Energy is taking, that government has adopted in the US the role of soft power in saying that rather than regulate some things, we will require the government to lead the way. And as it is one of the major purchases, it can ripple down. So to sell into the government, you have to meet standards. And then your entire supply chain below you is going to have to also come up to those standards. So it is an interesting way comparing the two different countries and systems. Now, I have been told that we've really kind of gone over time, but I just enjoyed this panel so much because I knew I had such interesting, deep thinkers with such great experience in this space that I was very pleased to get the chance to dive in. But we have more fun coming. So I would just like to very much thank our panelists, Aidan, Andrew, and Kira.
Thank you so much. I second that. I enjoyed both the breadth and the depth of all the topics that we discussed. Thank you so much. At the very least, I'm hoping that it has inspired you to consider robotics from a new angle, to think about sustainability and to consider how, as engineers, as product builders, we can bring technology to make a positive impact in our world. I'm sure you all want to take a small break. We'll take a 5-minute break, but just give me 30 seconds before that. Next up, we'll be having breakout sessions. These are more like a roundtable format, which means it will be more conversational. You can share your experiences, ask questions. We'll have a leader in each of those groups, and we have 5 different topics where we're going to dig deeper into each of them. The first one is building robots for tough environments. That's happening in the lobby to your right. And then the second one is generative AI and robotics. What's next? That's happening in Bay 1, just behind you. Third topic is sustainability and circularity for robotics products. That's happening in Bay 2, which is to your left. Fourth one is how to take a product from concept to market. At the end of the hall, it's Bay 3. And the last one is overcoming barriers to robotics adoption. It's in Alamo, which is at the end of the lobby. There's a room there. So yeah, please, if you have signed up for one of these breakout sessions, I encourage you to go to the same session because we have limited space. If you have not, just find one of the topics that is interesting for you. We have amazing facilitators leading this, from Horizon Robotics to Arcadia Tractor to Omnicell. You will know who they are when you get there, and I encourage you to go to those breakout sessions. The breakout sessions will start at around 4:20. So on the way, grab maybe a snack or a drink, and the breakout sessions will end at like 5. We'll have a happy hour following that, so the bar will be open. There'll be drinks. So there'll be a chance to network with other like-minded professionals here. And as you are enjoying your drinks, also take a look at some of the demos we have here. It's dispersed around the space, and talk to people that you find interesting. We're not coming back to the main stage, so I want to just say a big thank you to all of you for coming here this afternoon. all our presenters, but all of you, I mean, there's so much knowledge here, and I know that we have just started. We could continue this conversation for the rest of the evening, but I hope that this will inspire you to take the conversation back to your workplaces or friend circle and continue to build products that make a positive impact in our world. Thank you so much.